Hello everyone, I'm Shaurya and I'll be giving you the solution video for third problem in your latest 30 days of code contest. I hope you guys enjoyed doing the question and giving the contest. So let's go to the problem state. So in the problem, you are given an array of of length n. You want to find the maximum possible bitwise AND among all the subarrays. Then you also want to maximize the subarray length as well, right? So what you want to do, you want to find the maximum possible bitwise AND among all the subarrays, and then you have to maximize the subarray length as well. So if you are given an array, there will be multiple subarrays of it, and you will take AND of that subarray, and you will find the maximum bitwise AND that you can achieve. And after you have achieved that, you also want to maximize the subarray length. But there's a twist. Shaurya can insert at most d elements into the array of any value at any position at any moment into the array. Okay, so you can insert at most d elements of any value of your choice at any position at any moment into the array. So now the task is he must find the bitwise AND of all the elements in the subarray, that is maximum among all the subarrays. The subarray length is also maximized. Sorry. So among all the subarrays, we have to find the subarray with maximum possible AND value, and also after we have find that, let us call us that k. So k is the maximum possible bitwise AND among all possible subarrays of A, right? After we have found k, then we have to find the subarray with maximum length as well. So now the definitions are here. What are subarrays? Basically, we get subarrays from after deleting some elements from the front and from the back. A subarray is a contiguous sequence of in the element, right? So this is a subarray after deleting some elements from the front and some element from the back. What is bitwise AND? Bitwise AND is an atomic operation. What we can do is 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is also 0. So these are the properties of bitwise AND. You might have studied in your class 12th or first year of your coding journey. So now what is k? K is the maximum possible bitwise AND among all the subarrays. Now what our objective is? Our objective is to find the bitwise AND of all its elements, that is equals to k. You may insert at most d additional elements of any value into the array at any positions to maximize the subarray length. Okay. Now the given input is, you are given n, the length of the array, d, the maximum elements you are allowed to insert, then the array itself. N can go up to 1e5, d can go up to 1e5, array of I can go up to 1e9. Okay, standard input. Now the output is, you have to output the single integer representing the maximum possible length of subarray where the bitwise AND is also maximized to k. That is the maximum possible AND among all the subarrays after inserting d elements. Obviously, you will insert the d elements to maximize the length. If you wish to not insert, it's your choice, but that is the maximum elements you can insert. But obviously, anyone will choose to insert these elements to maximize the length. Let's discuss the sample. The sample input is the given length is 1, d is 1, so the array is 1. And then let's after inserting the element, the array becomes 1 comma 1. Why I chose 1? You will see. Here the value is 1, the subarray is 1, and the bitwise AND is 1. The subarray is 1, the bitwise AND is 1. The subarray is 1 1, bitwise AND is again 1. If I would have chosen a different value of other than 1, let's say if I have chosen 4, so the arrays will be 1 4 1 4. Here the k will be 1, here k will be 4, here k will be 0, right? So here the length is coming out to be 1, but in this case the length is coming out to be 2. That is maximum possible. Okay. So let's understand the question first. What the question is saying, you are given an array A. Okay. Let's say this is your array. There will be multiple subarrays. A subarray would be this, 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 this. Okay. And the subarrays will be starting from here, this, and so on. Similarly, some subarrays would be starting from here, this, right? So there are multiple possible subarrays. So among all the subarrays, we have to find that subarray which has the maximum possible end value, that we are saying k, and also the length is maximized. Let's take an example. Say the array is 1 3 3 2. Okay, what are the possible subarrays of it? 1 3 3 2. These are the subarrays of length 1. Then 1 3 3 3 3 2. These are the subarrays of length 2. Then 1 3 3 3 3 2. These are the subarrays of length 3. And then a subarray of length 4, that is 1 3 3 2, the array itself, right? Here the end will be 1, end will be 3, end will be 3, end will be 2. Here the end will be 1 and 3, that is 0 0 1 and 0 1 1. End will come out to be 0 0 1. Here the end will be 1. Here the end will be 3 itself. You can see 0 1 1 0 1 1 0 1 1. Here the end will be 2. Here 1 and 3 was 1, 1 and 3 was 1, 1 and 3 was again 1. Here 3 and 3 was 3, and 3 and 2 was 2. So the end is coming out to be 2. Here 1 3 3 is 1, 1 and 2, 1 and 2 0 0 1 0, that is 2, and 1 0 0 1. The end will be 0 0 0. Here the end is 0. So among all the possible cases, the maximum end is coming out to be 3, right? 3 3 3. So there are 3 subarrays with the maximum possible end value, that is k is equals to 3, and that is this one. Let me mark it with red, sorry, green. This one, and this one, right? And in this the length is 2. So our current answer is 2. Now what we can do, we can add the additional d elements into this, and then we will get the answer, right? So d was just an offset. It was nothing to be worried about. It was just to manipulate you. Okay, so how to approach this problem? First, let me discuss the brute force manner or the simulation part. I would suggest to watch this video at 2x. I'm going slow to cover everyone. So the brute force is, I will find all the subarrays. Find all the subarrays. In those subarrays, find k. Let's say find bitwise end of all the subarrays. And of all, and then in those bitwise ends we will find k, that is the maximum possible bitwise end, maximum possible end, right? So this will be the simulation for the problem, and then after we have found the value of k, we will find the length. We will also maximize k. So how can we find all the subarrays? The code will be pretty simple. We will first move a pointer from I is equals to 0 to n. Then we will move a point. Then let's say current the value is a of I. Then we will move a pointer j from I plus 1 to n, and then at every movement we will take current and equals to a of j. Okay, and then we will keep a pointer k as maximum of k comma cur, right? And that's how we can find k. And after finding k, we can maximize the length. If you want, you can put a check here also to to find the value of k, also find the maximum length, or you can keep it in a separate loop. But the problem with this approach is, can you guys see, like in this approach what we are doing, we are putting a loop here. The worst case it can go up to 1e5, and we are putting a loop here. The worst case it can go up to 1e5. So it is a big O of n square approach, right? It will give TLE in our current constraints. Though this approach is correct to find all the subarrays and then find value of k, but it will surely lead to TLE. So how we can optimize it? Okay, so that's our thing. So how we can optimize it? For that we have to look a special property of bitwise AND. So when we take bitwise AND of two values, say a and b, say we take a and b, इसका हम लोग जब whenever we take bitwise AND of these two values, it will be always less than equals to minimum among a and b. Okay, this is the property of bitwise AND. Let's prove it in a very intuitive manner. Say a was something as 1 1 0 1 1 1 1. Okay, that is nothing but 15, and b was, say let's assume b is less than a. Okay, so b was something, if this bit is set, rest these bits will be set or not set, right? Suppose this one was set, this one was not set, this one was set. So after taking AND, what will come? 0 1 1 0 1. Okay, that is b itself, and among this you can see b was minimum. Okay, and suppose let's say a was 0 1 0 1 0 1 1, and b was 0 1 0 1 0. Now bitwise AND will be 0 1 0 1 0. So it is lower than b, right? No, it is coming out to be again b. Yeah, I have to take this one as 0. Suppose this one is also 0, and this one is also 0. So okay, I guess you get my point, that a and b will come out to be less than equals to minimum of a comma b, right? So this is the property we will use. Now how we will use this property? Among all the subarrays, you guys agree, in an array there will be a maximum element, right? In an array there will be a maximum element. Let's say in this array the maximum element lies here. Now it will be part of some subarrays, let's say this array or this subarray, right? So whenever it will be part of any subarray, those elements will always decrease its value. We can see 3 was the maximum among this. When the 3 was part of this 3 was in part of this 3, it did not decrease its value. But when 3 was in part with this 2, it became 2, right? When this 3 was part in with this 1, it became 1, right? When this 3 was in part with this 1 3 3 2, it became 0. So the maximum element in the subarray, if it gets involved in any array, in any sub-array, then the value will come out to be less than equals to maximum. Minimum. Right? So our value of k is nothing but the max element in the array. Okay, so this we can find in big O of n time complexity. After that, we have found k, right? Now what we have to do, we have to find the longest contiguous length of k. Longest contiguous length of k. Right? Say let's say the array was 1 3 3 2 3 3 3 1 3 2 1. Okay, so in this k will be nothing but 3. You can find all these subarrays and you will come to realize that the maximum possible bitwise AND that can possible in this subarray is nothing but 3. And then after that we will find the contiguous lengths of 3. Here the contiguous length is 2, here the contiguous length is 3, here the contiguous length is 1. Right? So among this length is the maximum. Let me mark it as red. This length is maximum. So our answer is nothing but 3. Okay, and then we can add the additional d elements into the array. Let's say d was 2. We can add 2 3s here, 2 3s here, 2 3s here, separately obviously. So in this again the answer will be this 2 3s plus 3. So here it will be 3 plus 2, that is equals to 5. D was 2 in this case. Right? So I hope you understand what I'm trying to say. Let's go to the code and send it. See what I did. I simply took the input n and d. Here the n is 3 and d is 2. Then I took the vector input. Then I've said my k is max element in the array. This is big O of n. And then after I have found my k, I'm counting the maximum possible length. Maximum length of contiguous case. Sorry for that. Contiguous case. Right? And then at the end my answer is maximum count plus t. So let's do a quick dry run of this code. Like suppose the array was 1 3 2 3 3 2. So my k is nothing but the maximum element, that is 3. You can use this STL star max element. Basically max element will return you the pointer of the array, and by star you can get the element. So this works in big O of n time complexity, and you can write the naive code as well to find the maximum element. So I initialize my max count as 0 and count as 0. First it will see 1 equals to 3, no. 3 equals to 3, yes. It will increase the count. C and T will become 0 to 1. And at every step we will check the max count value as well. Okay? Max count updates to 1. Then it comes to 2. Is 2 equals to 3? No, 2 is not equals to 3. So it will again set count as 0, but max count will remain as 1. Then it will check 3. 3 equals to 3, yes. Update count. Max count will remain 1. 3 equals to 3, yes. Update count 2. This time max count will also update to 2. Then 2 equals to 3, no. Update count to 0. Maximum of 2 comma 0 is 2. So the length was coming out to be 2 as maximum. And at the end we will add d, that is suppose in this d was 5 given, so we will add 2 plus 5, that will be nothing but 7. So I hope you guys understood the solution video. You can comment if you have any doubt. And this was a solution video presented by TCP. Thank you so much.